students, in previous video you have studied about the ionic bond or electrovalent bond. You have seen that it is formed by transfer of electron from one atom to another atom, and it was formed between metal and non-metal. Metal loses electron and form cation. Non-metal gains electron and form anion. And the electrostatic force of attraction holds them together. In this part, we will study about the covalent bond. It is another type of bond which is formed between two non-metallic atoms. That is, again remember, metal and non-metal combine to form electrovalent bond or ionic bond, whereas two non-metallic atoms combine to form covalent bond. So let us start today's topic, that is covalent bond, the another type of bond. Covalent bond. The chemical bond formed by mutual sharing of one or more pairs of electrons between two similar or different non-metallic atoms. Now you see here again in the definition it is given that it is formed by mutual sharing. That is, both the atoms will impart their electron for sharing, and they are utilized or used for their stability by both the atoms involved. Now this is called covalent bond. As you have seen, it is formed by mutual sharing of one or more pairs of electrons between two similar or different non-metallic atoms. Because as you know, non-metals have 4, or we can say directly from 5, 6 or 7 valence electrons. They have tendency to gain electron. They cannot lose electron. So if there are two non-metallic atoms involved, then neither one of them will be able to lose electron. So there is only one option, that is to share the electrons in between themselves. So they share electrons between them. So now you can remember here, that is, the covalent bond is formed by mutual sharing of electrons between two non-metallic atoms. Now the question is asked that what is covalency? Here, as in electrovalency we have studied, the number of electrons lost or gained by an atom is called electrovalency. But here sharing has to take place. So the number of electrons shared by one atom or by an atom during formation of covalent bond is called covalency. So number of electrons shared by an atom of element with one or more non-metallic atoms is called covalency. Like suppose if we have hydrogen, atomic number 1, configuration 1. It requires one electron to become stable. So it will share one electron, hence its covalence is 1. The chlorine has valence electron of 7. It will require one more electron. So it will have to share just one electron with the another atom. Its covalence is 1. Similarly, we will study later on in detail. Now, next part in it is, that is, what is the condition required for the formation of covalent bond? So, we write here conditions required. Conditions required for the formation of covalent bond. The first point, like in that is in ionic bond, we have studied about the terms ionization potential, electron affinity, and the electronegativity. These three terms will be used here also. Now, if an atom will have high ionization potential, then large amount of energy will be required to remove the electron. It will be difficult, which is the characteristics of nonmetals. So it will tend to share electron. That is, now you can write here, both the atoms should have high ionization potential. That is, they will require large amount of energy to remove electron, which will be difficult. So it is easier to gain electron, share electron. Means they will not be able to lose electron easily. Next, both the atoms should have high electron affinity. As a result, in that case, both the atoms have tendency to accept electron. Means they will not be able to lose electron, and so there will be the chance of only sharing, partnership of electron between the two atoms. Now, third, the difference of electronegativity between them should be 0 or negligible. Now you can see here, that is, the electronegativity is the tendency to attract electron. Now if the difference in electronegativity will be 0 or negligible, then neither one of them will be able to pull the electrons completely. They will have almost equal attraction, so there will be no transfer of electron, and hence they will have to share the electron. Now, so these are the three basic points, conditions required by for the formation of covalent bond. One more point can be written. Elements should have valence electrons 4, 5, 6 or 7. We also have written here that is 4. The element having 4 valence electron can neither lose nor gain electron. Although this is the characteristics of non-metal, but this is also, that is, the elements having 4 valence electron can neither lose nor gain electron. So there will be the only chance of sharing of electron. So these are the 4 basic requirements, or we can say conditions, for the formation of covalent bond. Now we will have to study here the type of covalent bonds and their examples. This is very simple. If you'll remember, if you'll follow the basic rules, the basic points, you will be able to draw the electron dot diagram more easily, without any doubt, without any hesitation. But always we will have to follow some basic concepts, basic rules. Like you see, now types of covalent bond. First, single covalent bond. Now, as the name suggests, single means the two atoms will impart one electron each. Hence, there will be the sharing of one pair of electron. That is, now you can see, it is formed by mutual sharing of one pair of electrons. Between two non-metallic atoms. Like you see, suppose example, we take first hydrogen. Now, what will be the basic requirement? Students, पहले भी हम बतला चुके हैं कि फर्स्ट ऑफ ऑल आप जो भी एलिमेंट इन्वॉल्व हो उसका एटॉमिक नंबर के साथ इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिख लो. You will determine whether it is metal or non-metal. Because in question paper, you will have to decide what type of chemical bond is it. It will not be given there. So how can it be determined? First of all, write electronic configuration. If there is a metal and non-metal, which will be determined by valence electrons, then there will be ionic bond. But if both of them have valence electrons 4 or more, 5, 6, 7, it will be non-metal, and hence there will be covalent bond. So in this case, hydrogen, atomic number 1, configuration 1. Now you see case cell 1. Hydrogen is a non-metal, which is the exception, having valence electron of 1. It requires one more electron to complete duplet. That is to acquire 2 electrons in the valence cell. 2 electrons in the valence cells. Now you see, one hydrogen atom has one valence electron, another hydrogen atom has another valence electron. So both of them require one more electron. As a result, there will be mutual sharing. One electron, both shares, and hence this electron is used by both the atoms. Since there is a mutual sharing of one pair of electrons, so it is called single bond. It can be written, if there is one pair of electrons shared, then it is represented by a single line. That is H2, that is the hydrogen molecule. So students, if you will follow this simple concept, you will be able to draw the diagram of all the electron dot diagram of all the covalent compounds. Now, make it clear with some more examples. Second example, ammonia, NH3. Now you see that in ammonia, nitrogen has 7 valence electrons. 2, 5 is the configuration. Hydrogen has 1, hence 1. Now you see that is nitrogen has 5 valence electrons and it requires 3 more electrons to complete octet in the valence shell. Valence shell should have 8 electrons in order to become stable. It requires 3 electrons. But hydrogen has valency of 1. Here nitrogen has valency of 3 and it has valency of 1. That is, one hydrogen atom can share only 1 electron. So what will happen? In that case, a nitrogen atom will share its 3 electrons with 3 hydrogen atoms. Each hydrogen atom will impart 1 electron. So how can it be written? Now you see, suppose nitrogen has 5 valence electrons. As you know, that is, while writing electron dot diagram, we use only valence electron. Now, so this is a valence electron, hydrogen. We can take another different symbol. Now, or we can write like this, 3 hydrogen atoms are required. Now, nitrogen, it requires 3 electrons. So first of all, it shares 1 electron with 1 hydrogen atom, that is 1 from nitrogen, 1 from hydrogen. Similarly, other electron again with another hydrogen atom, the third electron with another hydrogen atom. So it required 3 electrons, it has shared 3 electrons, and this one is the left, this one. Actually, this pair of electron which has not taken part in sharing is called lone pair. Lone pair, I will just define here. In that case, you see, nitrogen has completed its octet and each hydrogen has completed its duplet. Hence, all of them are stable. It can be represented as NH single bond. So this is a lone pair. There are 3 single covalent bonds. Now, here in this ammonia molecule, there is an unshared pair of electron that is also known as lone pair. So, just define lone pair. It will be useful in the next later topics. So first of all, let us define with lone pair. Then we will take more examples. Lone pair. The unshared pair of electrons with an atom in a covalent molecule is called lone pair of electron. So in ammonia molecule, this was unshared pair of electron, hence it is lone pair of electron. Now take some more examples. Suppose we have to take HCl. Again, proceed with the similar method. First of all, write electronic configuration. Now 287. Again you see, one hydrogen atom requires 1 electron to complete duplet. Similarly, chlorine has valence electron of 7, valence electron of 7. Its valence is 1, so it requires one electron to complete octet and become stable. This requires one, this one also requires one. So both of them will share their one electron each. Now you see here there is one electron shared by each other. Hydrogen completes duplet, chlorine completes octet. Students, in covalent compound, if it is asked to draw the electron dot diagram, then you can directly draw this part only. You need not require to write this one, you can draw it directly. Now, so this is the hydrogen chloride single covalent bond. Now, you can solve yourself another example. Like suppose we take CH4, that is methane molecule. Now again you see, in methane molecule, carbon has atomic number of 6, configuration 2, 4, and hydrogen 1, just 1. As you have used the method to draw electron dot diagram in case of ammonia, you can proceed with a similar concept. Like carbon has 4 valence electron and it requires 4 more electron, but one hydrogen can share only 1 electron because it requires 1 electron to complete duplet. So again remember, carbon requires 4 more electrons because it has a valence electron of 4. Its valency is 4. But one hydrogen can share only 1 electron. So one atom of carbon shares its 1 electron each with 4 hydrogen atoms. In this way you see that all the 4 hydrogen atoms have their complete duplet and the carbon atom has its complete octet. This is called the methane molecule, or you can write it like its structure, this one, CH4 molecule. Now this was again the example for methane molecule. Take one more example. Suppose the another example is chloroform. The formula is CHCl3. Now again you see here, carbon has atomic number 6, configuration 2, 4, hydrogen 1, configuration 1, chlorine 17, configuration 2, 8, 7. Now again you see here that carbon requires 4 electrons. Hydrogen requires 1 electron, so it can share 1 electron with it. Chlorine requires 1 more electron, so 3 chlorine atoms will share 1 electron each with the 3 electrons of carbon. Now, so you can draw like this again. Carbon has 4 valence electrons. It shares 1 electron with 1 hydrogen atom, and there are 3 chlorine atoms. So each chlorine atom shares 1 electron with 1 electron of carbon. In this way, each chlorine atom completes its own octet, and carbon has also completed its octet by sharing its 4 electrons with 4 different atoms. So this is the chloroform or trichloromethane, or we can say that is methyl trichloride. Its structure can be written like this. So this is the chloroform molecule. Now take one more example. Take one more example. Now another example. Suppose we take ethane. Formula is C2H6. Just I have taken it for the convenience. C2H6. There is two carbon atom. This is the organic compound, also known as hydrocarbon commonly. Now, if there is more than one carbon atom, then for the basic information, now just first of all make a chain by sharing one electron by each carbon atom. Means first of all make a chain of carbon atom by sharing of one electron from each other, and then start sharing their electrons with hydrogen. Suppose there is 6 hydrogen atom. So first of all share one electron of carbon with each this hydrogen atom, and again for this carbon also share one hydrogen. Go for the another hydrogen atom. In the similar pattern you can go on distributing the hydrogen atoms. Now there is the another one here. So just you have seen, that is 4 electrons of each carbon atom has taken part in sharing either with another carbon atom or with hydrogen atom. In this way, now you see each carbon atom has completed its octet, or in structure you can draw here a structure of ethane molecule. So these were the different examples of single covalent bond. Now take second part, that is double covalent bond. Double covalent bond. Now as the name suggests, again double means two. That is, it is formed by mutual sharing of two pairs of electrons. Two pairs of electrons between two non-metallic atoms. Two non-metallic atoms. Now the non-metallic atoms may be similar or different, but the conditions will be the same. That is, the difference in electronegativity should be either negligible or zero. Now you see here example. First O2. The electron atomic number of oxygen is 8, configuration 2 6. So one oxygen atom requires 2 electrons to become stable, to complete octet. At the same time another oxygen atom also requires the same number of electrons, that is 2. Hence the two oxygen atoms will share 2 electrons with each other. That is, both the oxygen atoms impart their 2 electrons and leaving behind the remaining 4 electrons. Hence the double covalent bond is formed. So this is the oxygen molecule. Now take another example. CO2. This time again you will proceed with the similar points, similar method. Like carbon, atomic number 6, configuration 2,4. Oxygen, atomic number 8, configuration 2,6. Now here you can see, like in single covalent bond, on the basis of number of electrons required, they take part in sharing with another atom. Here again, carbon requires 4 more electrons, but one oxygen atom requires only 2 electrons. So one oxygen atom can share only 2 electrons. To fulfill the requirement of carbon, 2 oxygen atoms take part, sharing their 2 electrons each. In that case, carbon, first of all, it shares its 2 electrons with one oxygen atom and another 2 electron with another oxygen atom. Valence electron 6, 2, 4, 6. Now, each oxygen atom has completed its octet, and carbon atom also has completed its octet. Hence, C double bond O, double bond O. So, these are the double covalent bonds. Double covalent bonds. Now, so this was the another example. Take one more example from the hydrocarbon part. Hydrocarbon part, like suppose we take ethene, or commonly known as ethylene. Ethylene, that is C2H4. Again, as in single covalent bond, the last example was ethane having 2 carbon atom. We have used it. Take again, there is 2 carbon. So first step is to link, to bind up the 2 carbon atoms by mutual sharing of electron between them. That is, first of all, make chain of carbon by mutual sharing, and then further distribute the hydrogen atoms by sharing their electrons, like 4 hydrogen. Now start to distribute hydrogen. One hydrogen shares 1 electron on this side. One hydrogen again shared here. Come for the another hydrogen. Again for this one. But now you see that there were only 4 hydrogen atoms which are used up. But the 1 electron of each carbon atom is left. Only 3 has taken part in sharing. 1, 2, 3. 1, 2, 3. That is, 1 electron of each carbon atom is left. They have not completed their octet. So what will happen? At the end, the leftover electron will be used by carbon atoms for mutual sharing. So you can again use that similar electron. Hence, on this side, here, single covalent bond, and then here, double covalent bond. You can write like this. So, these were the different examples of double covalent bond. Now take another part. Third, triple covalent bond. Triple covalent bond. As the name suggests again, like the first one, previous one, it is formed by mutual sharing of 3 pairs of electrons. 3 pairs of electrons between 2 non-metallic atoms. Non-metallic atoms. Like example, again, N2 nitrogen molecule. In single covalent bond used hydrogen, you can have a chlorine molecule and so on. double covalent bond oxygen, here nitrogen. Nitrogen has atomic number 7. Its electronic configuration is 2 and 5. Now you see, this nitrogen atom requires 3 more electrons to become stable. Another nitrogen atom will also require 3 electrons. So, between the two nitrogen atoms, 3 pairs of electrons are shared. Means 3 electron is imparted by each nitrogen atom, and hence triple covalent bond is formed. Due to the formation of triple covalent bond between nitrogen atom, nitrogen gas is chemically inert. It does not take part in chemical reaction easily because large amount of energy is required to break the triple covalent bond between two nitrogen atoms. Again, take another example of it. Ethyne, that is C2H2. You have previously used C2H6 for single covalent bond, C2H4 for double covalent bond. Now here it is C2H2. Again proceed like similar pattern. First of all, there are 2 carbon atoms, so make a chain of carbon atom. If there will be 3 carbon atom, in another example like C3H8 and so on, then you will first of all make chain of carbon atom by mutual sharing, and then distribute hydrogen. Like here 2 hydrogen are there. Share 1 hydrogen with each carbon atom. Now the hydrogen atom is not left. But the carbon is unstable still because it has used only 2 valence electrons. 2 valence electron of each carbon atom is left, has not been used up. So here 2 electron of this one is left, 2 electron of this one is left, and they are required to be shared. So the remaining 2 electron of both the carbon atoms are mutually shared. Hence, in this way, triple covalent bond is formed. That is C triple bond C triple bond a single bond H. So students, you have studied the 3 types of covalent bonds, the conditions required, the method, the simplest way to draw the electron dot diagram of single covalent bond, double covalent bond and triple covalent bond. We will further study ahead the polar non-polar covalent bonds, the characteristics of covalent compounds, and then after that we will study oxidation and reduction.